You hit the ball when it falls back to a height of 4 feet. Now let's get a picture of this, okay? Here's the person. And they toss the ball right here. They're holding a bat in their hand, okay? They toss the ball up into the air. So from here to the ground is 5 feet, okay? So they're holding the ball 5 feet off the ground. Got it? They toss the ball up. So the ball goes up. And when it comes down, he strikes the ball at a height of 4 feet. So when the ball is about right here, that's when you swing the bat and hit the ball. Okay? So there's a little picture of what we're doing. So at the beginning of this problem, at the start, the starting height, the ball is 5 feet from the ground. When the ball is contacted, the ending height is 4 feet. Don't forget that, okay? You toss the ball. When you toss the ball, it's 5 feet above the ground. When you hit the ball, it's 4 feet above the ground, okay? Your initial velocity is 25 feet per second. Now here's the formula I told you to use with a velocity or a throw situation. Negative 16t squared plus vt plus s. Now don't forget, s is still your initial starting height. H is your ending height. Time is still, t is still your time. Your time still must be in seconds. Your height must still be in feet, and your velocity right here must be in feet per second, which makes sense because you're dealing with feet in seconds. Okay, so here we go. My ending height is 4. My velocity, now remember, if you toss it upward, positive velocity. If you toss it downward, negative velocity. He tosses the ball upward, okay? 25 feet per second. So put a 25 for V, then put your T. And your initial starting height for S is 5. Wow, look what we have, guys. It says, how much time will pass before you hit the ball? Well, guys, come on, think about it. I mean, really. You've got a quadratic equation. You've got a variable with an exponent of 2, and that's the highest exponent you have. Unfortunately, we have a t term or a b term, whatever you want to call it, so we're going to have to use the quadratic formula or completing the square. I'm going to go with the quadratic formula. So here we go. 0 equals negative 16t squared plus 25t. Now what I did is I brought the 4 over and I made it negative 4. So I'm left with a positive 1 here. That's why there's a 0 here. So my a is negative 16, my b is 25, and my c is 1. Okay? So my formula is, as you guys should know by now, negative b plus minus the square root of b squared minus 4ac all over 2a. So b is 25, so negative 25. Square root of b squared. B squared is 625. Then I have negative 4, and then in parentheses, a times c, negative 16 times 1. That's negative 16 all over 2a. Now a is negative 16, so 2 times negative 16 gives me a negative 32. Alright? Now, if you take negative 4 times negative 16, you get a positive 64. So 625 plus 64, under your radical, you're going to have a 689. And of course, you still have a negative 25 here, and you still have a negative 32 here. Now, if you take the square root of 689, you will get, rounded of course, you will get 26. So I rounded that to 26. Alright, now let's clear out some space here. Alright, you can always pause the video if you need a copy of this down. I'm about ready to erase it, okay? Alright, here we go. Now, first of all, I'm going to take negative 25 plus 26. That's positive 1 over negative 32. Then I'm going to take negative 25 and negative 26. That's a negative 51 over a negative 32. Now, how much time will pass before you hit the ball? I can immediately discard, throw away this answer, because a positive over a negative is going to give me a negative answer, a negative number, and time cannot be negative, so I don't need this. Now, negative over a negative is positive. 51 divided by 32 is 1.6, and of course, that's a positive sign right there. Time in this throw formula is seconds, so that's how much time you have. You have 1.6 seconds to hit the ball. Alright, number 42. For 1987 through 1994, the number of cell phone subscribers can be modeled by this model here, T. When T equals 7, that represents 1987. In what year do cell phone companies have about 7.5 million subscribers now? I wasn't sure if we'd need this graph. It doesn't look like we do. I'm going to put it way down here, but I'm pretty sure we're not going to need it. Now, as for the rest of this problem here, first of all, notice your S is subscribers in millions, okay? Your T is time in years. So here we go. In which year did cell phone subscribers have about 7.5 million subscribers? So I'm giving you the subscribers, substitute this in for the subscribers. So I have 7.5 equals 0.52 T squared minus 7.94 T plus 31.87. Alright? So here's what I have to do now. I have to solve this equation for T. Now, yes, we have decimals, and yes, that's going to be a pain, but other than that, it's really not too difficult, guys. Look, we notice we have a quadratic equation, so we need to bring this over and make it a negative 7.5. Alright, so here's what you're left with. 0 equals 0.52 T squared minus 7.94 T. And then we have positive 24.37. Now, I'm going to put A above this. There's my A, there's my B, and there's my C. So here we go. Negative B plus minus the square root of B squared minus 4AC all over 2A. And let's copy this so I don't have to keep writing it every time. Alright, so negative B, B's already negative, so negative would be a positive 7.94 plus minus the square root of B squared, so 7.94 times 7.94 is 63.0436. 63.0436. And then negative 4, and then AC. So A times C, 0.52 times 24.37, we're going to get 12.6724. 12.6724 all over 2A. A is 0.52, so 2 times 0.52 is 1.04. Now, I'm not going to take a lot of time and simplify the radicand. Remember, the radicand is the number under the radical, okay? I'm not going to take a lot of time and simplify that for you. I'm just going to say we have a negative 4 times a positive 12.6724. You'll get a negative number, then combine that with 63.0436, and your radicand will be 12.354. 12.354. Outside here we still have your 7.94. In the denominator we still have 1.04. Now, the square root of 12.354, of course rounded, is going to be 3.5, so I rounded to one decimal place. 3.5 all over 1.04. Okay, now, excuse me. Now, having done all of that, I have two answers here. First of all, I'm going to take 7.94. Let's do it this way. It's a lot easier. Let's do it like this. First, I'm going to have 7.94 plus, or positive, 3.5 over 1.04. Then I'm going to have 7.94 minus 3.5 all over 1.04. Now, let's see this here. I'm looking at my work here. Hold on 1 second. I'm getting 11. Now let me try to figure out why. Okay, I understand why. Okay, if I take 7.94 plus 3.5 divided by 1.04, I'm going to get 11 exactly. So there's one answer, okay? Now, 7.94 minus 3.5, hit enter, then divided by 1.04, and you get 4.3. Now, if you'll listen, I can explain to you very easily why one of these answers doesn't work. Please watch, okay? Now, this model, now please listen, this model only runs from 87 to 94. Got it? And when you get 7 out for t, that represents 1987. So 7 corresponds with 1987. So what would 4 correspond with? 4 would correspond with 1984, wouldn't it? Well, that's an impossible answer. Guys, look. This model only works from 87 to 94. Okay? So, that's out of our range for this problem. 11, though, works. If 7 is for 1987, 11 would be for 1991. And that is the year that the cell phone subscriber in America hit 7.5 million subscribers. Okay? Okay, guys, watch it again if you need to. I hope that made sense. Number 43. Okay, gravel is falling 4 feet from one conveyor belt to another. Because of the way the conveyor belt is constructed, the gravel is given a slight downward velocity of 1.4 feet per second. How long does it take each piece of gravel to fall? Now listen, they tell you there's velocity involved. They tell that to you. There's no secret. Because of the way the belt is constructed, there is a slight downward velocity. Okay? So if we have velocity, here's the formula we're going to use. Anytime we have velocity, or in other words, throwing power behind the object, we're going to use this formula, okay? Now, your starting height, your initial height is 4 feet. Starting height equals 4. Now here's where it gets confusing unless you'll listen to me. I'll help you understand this. Your ending height is really hard to figure out. Let's say here's the ground down below, okay? And let's say you've got a conveyor belt right here running along, okay? Then up higher is your other conveyor belt, okay? And the distance from here down to here is what? 4 feet, that's what it says. Gravel is falling 4 feet from one belt to another belt, okay? So, you're probably saying, what do I do? Because I don't know what the height of this is off the ground. Hold it, guys. Hold on a second. It's saying it's falling 4 feet to this conveyor belt here, okay? It's not telling you the height of either conveyor belt, is it? No, it's not. So there's no way that you can know the ending height off the ground. So what we have to look at is, are you ready? You have to look at this like this conveyor belt here is the ground, which makes sense because this conveyor belt right here is not 4 feet off the ground. It's 4 feet above this conveyor belt. So you're going to this like it's the ground, and this is like 4 feet above the ground. So when it says your starting height is 4 feet, then your ending height will be 0, because we have no idea, first of all, how high this is off the ground, and secondly, we don't care, because it never said the rocks are 12 feet off the ground or something. It says it's 4 feet above the conveyor belt. So we look at this like it's the ground, and this is like 4 feet off the ground. So we have a starting height of 4 and an ending height of 0. Alright, so here we go. Ending height, 0. Velocity, now remember, downward velocity is negative, so negative 1.4. And then my initial height is 4. So right away I realize I have a quadratic equation. So I'm going to have to get the right side, get one side equal to 0, and then use my quadratic formula. Okay, so here we go. 0 equals negative 16t squared. Positive negative is a negative 1.4t. Positive 4. Okay, so here's my A, here's my B, here's my C. Okay. Alright, so I have a negative, and then my B is already negative, so negative 1.4 is a positive 1.4. Positive negative, now B squared, so 1.4 squared, using your calculator, would be 1.96, then negative 4. And then AC, A times C, A times C, negative 16 times 4, negative 64. All over 2a. 2 times a is negative 16, 2 times negative 16, negative 32. Now, negative 4 times negative 64 would be a positive, I think, 256. I did it in my head, but I think it's 256. So a positive 256 plus a positive 1.96, you end up with a positive 257.96. Your positive negative is still here. Your 1.4 is still here, and your negative 32 is here. Okay? Now, if you take the square root of 257.96, you'll get rounded. You'll get 16.06. Your positive negative is still here with the 1.4. Okay? And then a negative 32. Alright, now, first of all, I'll have 1.4 plus 16.06 over negative 32. And the other answer would be, or the other fraction would be 1.4 minus 16.06 all over negative 32. Now here, if you type all this into your calculator, you're going to get out a negative 0.55. Negative 0.55. Over here, you're going to get out a positive 0.46. Now, there's your two answers for x, or for t, I should say. So t equals this, and it also equals this. Okay, now, having said that, let's get rid of all of this. There's your two t answers. Okay, now, they're asking us how long does it take each piece of gravel to fall. Well, we know time can never be negative, so we can discard that answer. This is the only one that makes sense. So 0.46 seconds is how long it takes the gravel to fall from one conveyor belt to the other one. 0.46 seconds. Alright, number 44. From 1983 to 1993, the number B in millions of recreational boats owned in the United States can be approximated by this model right here. T equals 3 represents 1983, and what year were there 15.8 million recreational boats? So guys, this is pretty simple. I mean, same old thing. They give us a formula. They tell us how many boats there were, so we put it in for B right here, then we solve for T and find out what what year it was. So here we go. 15.8 equals negative 0.01 t squared plus 0.59 t plus 11.28. Right away, you can see you have a quadratic equation with a t term or a b term, so we're going to have to use the quadratic formula. So bring the 15.8 over and make it a negative 15.8. And we're left with negative 0.01 t squared plus 0.59 t minus or negative 4.52. Alright, so there we go. And t, notice this right here, guys. T equals 3 is 1983, okay? We'll look at that again in a second. Alright, now, so there's my quadratic equation I'm going to solve. This would be my A, this is my B, this is my C, and there's your model. So here we go. Negative B, B is 0.59, so negative 0.59. Positive negative the square root of B squared, so 0.59 squared is 0.3481. 0.3481. Then negative 4, then AC, A times C, negative 0.01 times negative 4.52. That gives you a positive 0.0452. And then the bottom 2A, A is negative 0.01. Here's A. So 2 times negative 0.01 is negative 0.02. Now, if you simplify under your radical, which by now you should be able to do with your calculator, you're going to get positive negative, and this number under the radical, 0.1673 all over negative 0.02. Now, if you find the square root of 0.1673, you're going to get 0.4090. Over negative 0.02. Now, so here's what we have. We have negative 0.59 plus 0.4090 all over negative 0.02. And we also have negative 0.59 minus 0.4090 all over negative 0.02. Okay, so if you type all of this into your calculator, you will get out, let's see, 0.59 negative 9.05. And if you type it into this if you type this into your calculator, you will get out 49.95. So there are your two answers for T. Okay? Now, let's look at the problem and see what they're asking us to do. Here we go. We're looking for the year. Now remember, 3 corresponds with 1983. So 9.05 would correspond with 1989. 49.9, that's basically 50. 50 would correspond with, let's see, zeros 80, 20, 30. There we go. Now, this model right here is good from 83 to 93, okay? So we can discard this answer because this answer here is telling us the year will be 2030. Now that's okay for predicting future things, and we can definitely use equations to do that, but that's not what they're asking us here. It's past tense. In what year were 15.8 million recreational boats owned, plus your answer has to fall within this area here. And so this answer here, 9.05, which corresponds with 1989, does fall within our years that were allowed. So there's your answer right there, 1989. Okay, let's continue on to page 259, or 269, I believe. 269. Now, let's go ahead and take a look at number 29. A friend's family has built a fence around 3 sides of their property. Okay, let's get a better picture of this. 3 sides of their property, okay? In total, they used 550 feet of fencing. By their calculations, the lot is 43,560 square feet. Is this correct? Is this possible? Okay, well, let's see here if it is. Here we go. We know that this side is X. This side is X. We're going to call this side Y. Okay, well, to be honest with you guys, I'm trying to think if I really need to, well, let's look at it like this. First of all, understand, I'm going to erase this Y for a second. I'm going to draw a line. Just sit back, relax, and watch and see if this makes sense, okay? I know that if I draw this from here to here's X, so if I draw a perfectly vertical line, that means from here to here is also what? X. Now, there's a little bit, okay? There's a little bit of left over right here, okay? I'm not sure how much that would be, alright? But we could call it Y, but I'm going to appeal to your common sense, okay? Just think this through for a second and see if this makes sense, alright? If I have X, let's just pretend for a second I have a square, okay? Everybody got that? Just forget this area right here, just for a second, listen to me. I've got a square, so the area they're claiming is 4356, okay? So that means X times X. If I take length times width, I should get 43,560, or a little bit less than that, okay? Take the square root of both sides, and I'm going to get 208.7, so about 209. Now, if X is truly 209, are you listening? That means from here to here is how long? From here to here is how long? From here to here is how long? Plus a little bit more right here. Now I know what I'm doing there is not exact, because really the entire area is when they say the entire area is 43,560. Listen guys, that also includes this little sliver over here. But what I'm doing is estimating and using common sense, which you can do on a test. Now look, if this is 209, this is 209, this is 209, that's 627 feet of fencing. In total, how many feet of fencing did they use? Guys, they used 550. There's no way they have that big of an area, even with this little bit of space over here left over. There's no way. And so that's why the answer is no. So how would you explain that? I would say, in order to get this much of an area right here, you're going to have to use more than 550 feet of fencing. In other words, 550 feet of fencing is not enough to give you this area right here. It's just not enough, okay? Alright, moving on. Number 30. You have 100 feet of fencing. Do you have enough fencing to enclose a rectangular region whose area is 630 feet? How about a circular region whose area is 630 feet? Well, here we go. x. I'm going to call this y. Got it? Now you know by now. I never want to have an x and a y on my two sides. That's really going to be a pain. I mean, it really is. Okay? So, I'm going to try to write this over here so that it has an x, not a y. Now here's how I'm going to do it. This is x, this is x, this is y, this is y. I'm going to say x plus y equals 100, because look, I have 100 feet of fencing to go around my rectangle. Got it? So I add up all four sides equals 100. So now I have 2x plus 2y equals 100. Got it? Now I want to solve for y, so I can put something in for y and get rid of this y. Okay? So I'm going to bring the 2x over and make it negative. Okay, got it. Bring the 2x over, make it negative. Now divide everything by 2. If you want to put a 1 right there, you can. You don't have to. So look at that. Hey guys, what does y equal? 50 minus x. So instead of putting a y here, I'm going to put 50 minus x. Instead of putting a y here, I'm going to put 50 minus x. Now we're getting somewhere. So there's my 100 feet of fencing all the way around in terms of x. Now, they want to have an area of how much? 630, right? That's their goal. That's what it says. So let's see if it's possible. Here we go. Let's take length times width. 50 minus x times width. And that should equal your area, which is 630. Let's see if we get out a number for x. Let's see if it's possible, okay? So length times width equals area. Alright? Length times width equals area. There's my area, there's my width, there's my length. Alright, so take your x and multiply it through. X times 50 is 50x. X times negative x is negative x squared equals 630. So right away you see you have a quadratic equation. So you're going to want to get one side equal to 0. Let's put our negative x squared first, our positive 50x second. Bring the 630 over and make it negative. And I'm left with a 0. Now, there's a 1 right here, even though you can't see it. So this is my A, this is my B, this is my C. Got it? So, here's my quadratic formula. Negative B, B is 50, so negative 50. Plus minus or positive negative B squared, 50 squared, 2500. Minus 4 AC, negative 1 times negative 630, positive 630, all over 2 times A is negative 1, 2 times negative 1, negative 2. Now here's where the problem falls apart. If you take negative 4 times 630, you get negative 2,520. Negative 2,520. So positive 2,500, negative 2,520. That gives you a negative 20 under the radical. So you got negative 50. Positive, negative, square root of negative 20 all over negative 2. You're done. Finished. The answer is no. No, you can't do this. You cannot have 100 feet of fencing and have an area of 630. It's impossible. Look, I have a negative number under my radical. That means you cannot solve it. That means there's no x variable that will satisfy this so that you have an area of 630. So no. How do you explain it? Just put the quadratic formula failed, couldn't be used, or negative number under the radical. Now, how about a circular region? Well, that's interesting. A circular region. Well, let's really think about this for a second, okay? We can do this. A circular region. Alright, here we go. Let's see. If I have a circumference of 100, okay? So here's my circle. And I have a circumference of 100. What would my diameter or radius be? Let's see. Let's find out. What does circumference equal? Pi d, correct? Sure it is. Pi d. So I'll put my circumference here. Mr. Arrowhead, how'd you know you had a circumference of 100? Well, it says you have 100 feet of fencing. That means you're going to put a circular fence. How do I know it's circular? Right here. How about a circular region? So I'm going to start here and put up 100 feet of fencing. So that means my circumference is 100 feet. Alright? So circumference is 100. Pi, d for pi, I'm going to put 3.14. D, now divide both sides by 3.14, and I'm going to get 31.85. That's my diameter, so all the way across the entire circle. That line is 31.85 feet. Okay? Now let's find the area and see if it's 630 square feet. Alright, let's see. How do you find the area of a circle? Well, the last time I checked, the area of a circle is pi r squared. So I have to know the radius. So if my diameter is 31.85, then my radius is going to be 15.92. Half of this right here, 15.92. So the area of this circle is 3.14 times 15.92 quantity squared. Let me grab my calculator here. And I'm getting this for my area. It's easily taken care of. Easily. I'm getting 796. So yes, definitely. Do I have enough fencing to make a circular area whose area is 630 square feet? Yes, I have enough fencing. I've got plenty. If I make a circular region with 100 feet of fencing, my area is this much. So I can definitely make a circle that has an area of 630 square feet with the amount of fencing that I have. I'll have to cut some back and maybe only make it 90 feet or 80 feet or 85 feet or whatever it might be. But yes, I definitely have enough fencing because the fencing that I do have is enough to give me an area this big, let alone that big right there. Okay, alright, number 31. Randall High School's enrollment decreased for 20 years. However, in 75 it began to increase. From 55 to 95, the enrollment can be modeled by this, where t equals 5 is 1955. And what year was enrollment down to 300 students? So what year was enrollment down to 300 students? Well, enrollment is E, so where E is, I'm going to put 300, and we're going to solve for t. Alright, so 0.37 t squared minus 14.8 t plus 460. Alright, there we go. Now, right away I see I have a quadratic equation, so I know I'm going to have to get one side equal to 0, so we're going to bring the 300 over. And now you're left with this. 0 equals 0.37 t squared minus 14.8 t plus 160, because we bring the 300 over, make it a negative 300, and we're left with 160. Okay, so there we go. I'm now ready for my quadratic formula. And so let's see what happens here. Alright, here's my A, my B, and my C. So negative B, I've got a negative 14.8, so negative is a positive 14.8 plus minus the square root of 14.8 squared. 14.8 squared is 219.04. And then minus 4AC. 0.37 is A. C is 160. So 0.37 times 160 is 59.2. All over 2A. A is 0.37, so 2 times 0.37 is 0.74. And now we're done, because here's what happens. When you simplify this this expression under your radical, you're going to excuse me, you're going to get a negative number. In fact, I'll just tell you what it's going to be. Let me grab my calculator. You're going to take 219.04 minus 4 times 59.2. You're going to get negative 17.76 over 0.74. So as soon as you get this negative number, you know there's no solution to this problem. It can't be done. So the answer to this problem is there was never a time that Randall Curtin High School's enrollment decreased all the way down to 300. That never happened. It never got that low. Okay, so there we go. Alright, moving on to our last problem, finally, number 34. We've done a lot of these, probably getting a little boring, but it's our last one. Here we go. From 70 to 92, the sale of electricity in billions of dollars can be modeled by this. T equals 0 represents the 1980. S is in billions. Don't miss that. S is in billions. In what year did electricity sales reach 150 billion? So where my S is right here, I'm going to put 150 billion. And everything else will stay the same. Negative 0.22 t squared. Positive 9.38 t. Positive 105.21. Now, bring the 105 over and make it negative. Or bring the 150 over and make it negative. And we're left with the 0 equals negative 0.22 t squared. Plus or positive 9.38 t. And then if we combine positive 105.21 negative 150, we're going to get negative 44.79. Alright, so there we go. So now I'm ready for my quadratic formula. This is my A, my B, and my C. And here we go. B is positive, so a negative and a positive gives me a negative 9.38. Positive, negative, and then we have B squared. So 9.38 squared is going to give us 87.9844. 87.9844. Minus 4 AC. So negative 0.22 times negative 44.79. Negative 0.22 times negative 44.79 gives me a positive 9.8538. 9.8538 all over 2A, or 2 times negative 0.22. It's going to give you a negative 0.44. Okay, so there we go. Now, with my calculator, I'm going to type all of this in and get out a number for my radical. So negative 9.38, positive negative, and here we go. .5692 all over negative 0.44. Alright, there we go. Now, next, if we type this square root into our calculator, we'll get out negative 9.38, positive negative 6.96. I'm going to go and just make it a 7. 6.9 is close enough. All over negative 0.44. So I have negative 9.38 plus 7 all over negative 0.44. And I have negative 9.38 negative 7 all over negative 0.44. Alright. So here we go. Let's start with this one right here. Negative 9.38 plus 7 divided by negative 0.44. 5.40. We'll put 5.4. Now over here, negative 9.38 9.38 minus 7 divided by negative 0.44. We'll get 37.2. Alright. Now let's see, there's my two answers. Let's see how they tie into this problem, okay? According to this problem, looking for the year that electricity sales reached 150 billion. So T0 corresponds to 1980. 5.4 will say 5, that corresponds to 1985. 86 around in there. 37.2, 37 would correspond to what? The year would be 2017 or 2007. 2017. Okay, so I mean, look, this model is only good from 70 to 92, 1970, 1992, so this answer here is not going to work. It's not going to help us. However, this answer here falls right in the area, right in the region that this formula, this model is used for. So our answer is 1985. That is the year that electricity sales reached $150 billion. Okay, guys, I hope this homework help video has been help to you. If you have any questions, don't hesitate to call or email.